This is a video for Geometry Unit 6, circles. It's all about circles. So we're going to do problems 1 through 5. I did this awesome drawing. Alright, so let's talk about these. A circle is named by its center point. So this circle would be circle A, this would be called circle B. Alright, and then what we're talking about here is lines that touch a circle at one point. Those are called tangents. So this line you can see this is called tangent S. It has named by one letter. And then where it touches the circle is the point of tangency. So this is an external tangent. And then this one here is called an internal tangent. That's R, and it touches both of these circles at point M right there. All right, so question number 1 says, you're given a circle A is externally tangent to circle B. So that tangent S is tangent to both circle A and B. They say name the point of tangency of circle S name the point of tangency of S to circle A. So here's S, it's tangent to circle A at this point right here, J. All right, problem number 2. Identify the common external tangent. So there's internal tangents and external. So R is an internal tangent. So the common external tangent is this one, S. Number 3 says, radius AM has what relationship to line R? So this here, AM, is a radius. It goes from the center to the edge of a circle. That's called a radius. And if you draw a radius from the center to the point of tangency, it automatically is perpendicular to the tangent. So radius drawn to a point of tangency is perpendicular, is what they're looking for. Problem number 4, they say name a common internal tangent. So the internal tangent would be this one going through the middle. R is tangent to both circle A and circle B. And then problem number 5, how many possible tangents to circles A and B can exist? All right, so there's one here, and then one more could be drawn up here. So in total, 3 tangents, common tangents, could be drawn with these 2 circles. Our problem number 6 is a matching. What we're talking about here is chords and arcs, right? So a chord is a line that goes through a circle. It touches it at 2 points. Okay, a tangent just hit off the edge of it, but a chord hits it at 2 points. So this is a chord, and this is a chord here. So BC is a chord, DE is a chord. What they want to tell you is that if in the same circle you have 2 chords that are equal, then the arcs that they intercept are equal. So chord BC is drawn right here, then this is its arc, BC here. And DE, this chord is drawn, then this is its arc, DE. So if they tell you arc BC is equal to arc BD, so they say arc BC equals arc DE, then automatically you know that those lines, those chord BC, which is the line, equals chord DE. And the same thing the other way. If they tell you this chord DE equals the chord BC, then that automatically means that arc DE equals arc BC. All right, so those are the 2 different things. If arcs are equal, then chords are equal, and if chords are equal, then arcs are equal. And then the last one is if AX is perpendicular to BC, so that means right here, these 2 lines are perpendicular. The theorem that goes with this is that diameters that are perpendicular to a chord bisect the chord. Okay, so that means it cuts the chord in half. So if AX is perpendicular to BC, then BX equals CX. Because if a diameter to a chord bisects the chord, if a diameter is perpendicular to a chord, then it bisects the chord. All right, problems 7 through 9 are all about inscribed angles, okay? An inscribed angle is an angle that all 3 points are on the circle. So this angle like this. is called an inscribed angle. Inscribed angles are equal to half of their intercepted arc. So this angle intercepts this arc right here. If that arc is 100 degrees, that means this angle is 50. Likewise, if they give you one and they tell you this angle is 25, that means its intercepted arc is 50, okay? The angle is half of the arc. So that's what we're dealing with here. Okay, so we need to remember a circle has 360 degrees in it. And then intercepted arcs are equal, angles are half, inscribed angles are equal to half of their intercepted arc. Okay, so on problem number 7, it says, if arc DB, all right, so DB is only 2 letters. So that means it's not going to be over half the circle. See, you could go this way to get DB or this way. But if it's this, it's called the major arc. It covers more than half the circle. It would have to have another letter. It would have to say DCB. All right, so we're talking about this one right here, DB. Arc DB equals 140. Then angle A equals how much? So angle A is right here. It's intercepting this circle, this whole part over here. Okay, so everything but this is A's intercepted arc. So this much of the circle is 140. So there's 360 degrees. We're going to go 360 and minus the 140 that is arc DB. So that's going to be 220. So this arc over here is 220 degrees. A is its intercepted arc. It's its inscribed angle. Okay, so this inscribed angle here, A, its intercepted arc is 220. So this arc is equal to, angle is equal to half the arc. So half of 220 is 110. So this angle is 110, the arc is 220 because it's twice as big. All right, problem number 8. They say if the measure of angle C is 75 degrees. Okay, so this angle right here, oh, I'm missing a line right here. 75 degrees, right? Then what is the measure of angle BDR? So BDR is right here. Its intercepted arc is BD. Angle C, its intercepted arc is BD. They have the same intercepted arc, so they are equal. So if this angle is 75, this angle has to be 75 because they have the same intercepted arc. And then problem number 9, they say angle RDC. So RDC, this angle right here. Let me erase all these lines. Okay, angle RDC is 100 degrees, right? So this angle right here is 100 degrees. That means its intercepted arc, it's twice as big as it. So if this angle is 100 degrees, the arc is 200 degrees. All right, they want to know what is the measure of arc CD. So that's not this arc because it's over 180. That means it's over half the circle. They want the measure of this arc. So how many degrees are in one circle? 360, right? And then minus the 200 that's over here, and you'll have what's left, which is 160 degrees. All right, numbers 10 through 13 deal with secants, which are lines that go through the circle at 2 points and extend outside. Okay, so as in VU here, and UT, and tangents intersecting outside the circle. So these are actually pretty simple. An angle formed by 2 secants intersecting inside the circle, so that like angle 2 right there, is equal to half the sum of the intercepted arcs. So the intercepted arcs are VU and ST. So they tell you VU is 70 and ST is 50. So half the sum. So just add those, 70 plus 50, and then divide it by 2, and you'll have your answer. Then they ask for the measure of angle 1. The measure of angle 1 actually is number 10, and I just did number 11, all right? Number 2. Angle 1, this is number 10. Angle 1 is formed by two secants intersecting outside the circle. Same thing, except for instead of half the sum, it's half the difference. So instead of adding VU and ST, you're going to say VU minus ST divided by 2. So in this case, you go, this is number 10. 70 minus 50 divided by 2. That will give you the measure of angle 1. The measure of angle 2 would be half the sum. So they actually have different numbers on number 11. VU is 90 and ST is 60. So it would be 90 plus 60 divided by 2. So remember, inside is half the sum, outside is half the difference. All right, number 3, they ask for the measure of angle 3, which is formed by a tangent, this is a tangent, and a secant intersecting outside the circle. It's the same as two secants. It's half the difference of the intercepted arcs. So the bigger arc is VB, so you're going to say VB is 60. 60 minus, what's the smaller one? 40 divided by 2. So 60 minus 40 is 20 divided by 2. So the measure of angle 3 is 10 degrees, all right? Number 13, it's the same problem, but they give you the measure of angle 1 and want you to find V. All right, so remember, this angle 1 is equal to, it's outside, so it's equal to the measure of VU, arc VU minus arc ST divided by 2. All right, and then they give you the measure of angle 1, which is 40 degrees, and they give you the arc ST. So the VU is what we're looking for, minus 30 divided by 2. So rather than looking for this, you're looking for that. So to solve for this, move the 2 over, it's divided. So on this side it would multiply. 40 times 2 is 80 equals x minus 30, and then the 30 subtracted. So on this side it would add 80 plus 30, 110. So the measure of arc VU would be 110. All right, problems number 14 through 17. These are talking about central angles, okay? Central angles are angles that have their center, their vertex at the center of the circle. These are actually easier. Earlier we talked about inscribed angles. They are equal to half of their arcs, but not on these. Central angles equal their arcs. So if this angle is 50, then this arc is 50, okay? That's simply what we're doing here, all right? So they say the measure of angle 1, I'm sorry for that confusing, 1, 2, 3. The measure of angle 1 equals 50, okay? So 1 is here, and its intercepted arc is AB right here. Then they want to know, what is the measure of arc AB? So remember, central angles equal their arcs. If this angle is 50, then the arc is 50, all right? Then 15, we're talking about arc addition. They want to know, what is the measure of arc AB plus BC? So if you put those two arcs together, it's not over half the circle, so you're just going to call it AC, all right? Arc addition. If you don't go over half the circle, you can just call it by 2 letters. If you go over half the circle, then you have to call it by 3 letters, like ADC is what you would have to call that. All right, on problem number 16, they say the measure of arc 1 equals the measure of angle. The measure of angle 1 equals the measure of angle 3, which equals 30 degrees. Then arc BC equals how much? All right, so they want to know, what is arc BC? That does not look like a C. There. All right, so if this angle is 30, that means this arc is 30. And if this angle is 30, it equals this arc is 30. They tell us those are equal, and they're both 30. Now this line AD is a diameter. It goes from one side of the circle to the other, so it cuts it in half. So a half circle has 180 degrees in it. All right, and if this much of it is 30, and this much of it is 30, how much of it is left for arc BC? So you just have to subtract. 8 minus 6 is 2. 0, and 120. So that means this arc has to be 120 degrees. And then number 17 says, if the measure of angle 3 is 40 degrees, so here's angle 3, it's 40 degrees, then arc ABC equals how much? So ABC goes all the way from here to here. So this is a central angle. So if the angle is 40, then the arc is 40. This is a half circle, so 180 should be from here to here, but we got to minus that 40. So 180 minus 40 is 140 degrees. All right, starting with problem number 18. Now we're talking about the lengths of the segments. Okay, so this is two secants intersecting inside the circle. So the theorem says when two secants intersect inside of a circle, the products of the lengths of one secant is equal to the products of the length of the others. So product means multiplication, and so you're going to multiply the length of this side and that side equals this side and this. This is one secant. It's equal to 10 and x, and this one's 20 and 8. So 20 times 8 should equal 10 times x. So 20 times 8 would be 2 times 8, 160, equals 10x. And then to solve for x, 10 is multiplied. The opposite of multiplication is division. So 16 equals x. All right, then we move to the next problem, number 19, is a secant and a tangent intersecting outside the circle, like this. All right? The secant is x, and this one is 10 and 5. All right, so the formula for this is when a secant and a tangent intersect outside the circle, the tangent is the geometric mean between the length of the whole secant and the length of its external part. Okay, so the tangent, which is the line that touches the circle at one point, is the geometric mean. That means when you put it in your equation, it goes in a proportion on top of one side and the bottom of the other. All right, between the length of the whole secant, which is actually 10 and 5, which is 15, and the length of its external part, which is 5. All right, then you have to cross multiply to solve this. X times x is x squared, and 15 times 5 is 75. So x equals the square root of 75. 75 is equal to, it's not a perfect square root, but it is divisible by 25. 25 times 3. And then the square root of 25 is 5 square roots of 3. All right, next we have two secants intersecting outside the circle. So the theorem for that is the lengths of the segments is to find the length of the segment of the secant. You multiply the whole secant times its outside part equals the other secant, the whole secant times the outside part. So in this case, is this 9 and 3? Yes. Oh, this isn't 3, this is 5. Like something's wrong. Okay, 9 and 5. All right, so the product of the whole secant times its outside part equals the product of the whole secant times its outside part. So this whole secant is worth 14 because it's 9 and 5. So 14 times the outside part, which is 5, is equal to this whole secant, which you can't actually add. It's going to have to be x plus 3 times the outside part, which is 3. All right? So 14 times 5 is actually 70 equals, and then here you have to do distributive property. 3 times x, 3 times 3. 3 times x is 3x, 3 times 3 is 9. So then to solve for x, we want to move the 9 over. It's added. So on this side, it's going to subtract 70 minus 9 is 61. And then 61 over 3 is actually your answer. 61 over 3. All right. And then the last one in this segment is 2 secants intersecting inside the circle again. We have 2 lines like this, and they say it's perpendicular. It has this little square. All right. And this says it's a diameter. So this goes back to the beginning. If a diameter is perpendicular to a chord is a line that does not go, that goes and touches the circle at 2 points, then it bisects the chord. So this chord is cut in half. That means if this side of it is x, then this side is also x. So remember, 2 secants intersecting inside the circle, the products of the lengths of one secant are equal to the products of the lengths of the other. So product means multiplication, so that means you'd go x times x and 9 times 3. So x times x is x squared, 9 times 3 is 27. So x equals the square root of 27, which we already know is 9 times 3, and the square root of 9 is 3 square roots of 3. All right, number 22. They give you a circle, and then they give you 2 secants intersecting outside the circle. And they tell you this much of it is 40, and this is 20. Now, this is a diameter right here. So that means this circle is cut in half. And they've told you how much this is and how much that is. And what they're asking is how much this is. So you take your half circle, which is 180 degrees, minus 40, minus 20, and you have your answer. That's simple, all right? Number 23, this one's a little trickier, but it's not too hard. We have a circle and we have an inscribed square. Well, a inscribed quadrilateral, anyway. All right, and all they tell us is that this angle right here is 104 degrees, and they want you to say what this angle over here is worth. All right, so these are inscribed angles. See this angle here? Goes here to here. It's inscribed, and this is its intercepted arc. So remember, inscribed angles are equal to half of their intercepted arc. So the arc is twice as big. So if this angle is 104, means this arc is 208. All right? This angle that we're looking for, its inscribed arc, is the other part of the circle. Everything but this 208. So we need to take the whole circle, which is 360, minus the 208. Borrow 152. This arc over here is 152 degrees. So this angle is equal to half of its arc. So if its arc is 152, divide it by 2, and you'll get your answer for the measure of the angle. All right. Work hard. Remember these formulas. It's very important, all right? Don't go to the test not knowing, remember all your formulas for the measure of angles and the products. And the, the products and the measure of the angles and the segments. The last segment we did, the area of the segments and the angles.